Good morning students. Today in this video I will be discussing chapter 6 key concepts of class 10th NCERT CBSE syllabus. So the chapter I am going to discuss today is triangles. So let's see in detail. First, let's see two important properties of triangles. When do we say that two figures are congruent? Please recall that two figures are said to be congruent if they have the same shape and the same size. And particularly in this chapter, we would be studying figures which have the same shape but not necessarily the same size. So hence we can say that two figures having the same shape and not necessarily the same size are called similar figures. So hence we are going to study about similar triangles, and we can definitely study the difference between congruent and similar figures. If you see the topic 6.2, it is given as similar figures. We can say that all circles with the same radii, that is with the same radius, are congruent, whereas and also we can say that squares with the same side lengths are also congruent, and equilateral triangles with same side lengths are congruent. Whereas if we consider two or more circles, like as if given in 6.1 first figure, can we say that all these circles are congruent? No, right? Since all of these do not have the same radius, they are not congruent to each other. But we can say that they all have the same shape. So hence we can say that these are all not congruent figures, whereas these are all similar figures. So hence we can say that two similar figures have the same shape but not necessarily the same size. Therefore, we can say that in this figure 1, all the circles are similar. Right? What about two or more squares or two or more equilateral triangles as given in 2 and 3? We can say that as like in circles in first figure, here also squares as well as all the equilateral triangles, both are similar figures over here. They are not congruent. So from these figures we can conclude to a point that all congruent figures are similar, but the similar figures need not to be congruent. It's a very important point. Please take a note. Please make a note of it. Now, if you see the figure 6.3, these are the different photographs of the same monument, that is Taj Mahal's photograph, but they are of different sizes. Can we say that all these photographs are similar? Yes, sure, because all these are same, right? Whereas they differ only in their sizes. So hence we can conclude to another point that two polygons of the same number of sides are similar if their corresponding angles are equal. And first point is corresponding angles should be equal. That is first point. And the second point would be their corresponding sides are in the same ratio or in the same proportion. If these two conditions are satisfied, then we can say that two polygons are similar, which are having the same number of sides as well. Now here we can say that The same ratio of the corresponding sides is also referred to as the scale factor or the representative fraction for the polygons. So please make a note of it. So now let's solve exercise 6.1. Fill in the blanks using the correct word given in brackets. So first statement is all circles are similar. All squares are similar. All dashed triangles are similar. Equilateral triangles. Two polygons of the same number of sides are similar if A, their corresponding angles are equal. You have to write EQUAL, equal, but here I have no space, hence I have marked the symbol as equal. And their corresponding sides are proportional. So first you have to write equal, and for the second blank you have to write proportional. Now second question is given as give two different examples of pair of similar figures and non-similar figures. For the first, you can draw a small square or small rectangle and a larger rectangle. Here it is 1. The side, the length is 2 and breadth is 1, and here the length is 4 and breadth is 2. So hence 1:2 is equal to 2:4. Hence these are proportional. These are similar figures. And in case of non-similar figures, you can draw two different figures which are not at all similar. For example, if you draw a triangle and a square or rectangle, something like this, this is an example of pair of non-similar figures. Or the second example for this would be a rectangle and a triangle. And for the case of similar figures, if you draw a small circle and a larger circle, mark origin. Here it is, let's say 2 centimeter, and over here if you mark the center, and you can write this as 1 centimeter. So these are the examples. This one is for this left side is for similar figures, and the right side diagrams are for non-similar figures. Now the third question is state whether the following quadrilaterals are similar or not. So in the first figure it is given as rhombus. The second figure over here in the second diagram, it is a square. So we have to find whether both these quadrilaterals are similar or not. So to find whether two figures are similar, we have to check two conditions. First, that whether their angles are equal. Second, their sides should be proportional. If we see here very well, we can say that their angles are not at all equal, because in the case of square, all the sides would form a 90 degree, a right angle in all the sides, whereas in a rhombus it is not so. So hence angles are not equal. We can say directly that both these quadrilaterals are not similar. So hence we can write that since angles are not equal, these are not similar, right? So the answer is, since the angles of both the diagrams PQR is rhombus and ABCD square are not equal, hence these are not similar quadrilaterals. This is the answer for this question. So the next topic in this chapter is similarity of triangles. Till now we have defined what is congruency of triangles and similarity of triangles. Till now you guys would have got an idea that what do you mean by similarity of triangles. We can also recall that triangle is also a polygon. So hence, if there exists similarity for polygon, it also exists for triangles as well. So hence we can say that two triangles are similar if their corresponding angles are equal, and second is their corresponding sides are in the same ratio or in the same proportion. And please note that if corresponding angles of two triangles are equal, then they are equiangular triangles. And Thales, who is a famous Greek mathematician, gave a very important truth relating to two equiangular triangles. That is, statement is given as the ratio of any two corresponding sides in two equiangular triangles is always the same. And this result is called as basic proportionality theorem, or also known as Thales theorem, because he is the founder of this theorem. Hence, this theorem is extensively used nowadays, and it is a very important theorem from examination point of view. So basic proportionality theorem 6.1, I have already given a separate video. I have already put on a separate video on basic proportionality theorem. Check out the description for that video. And that's all for today's video. I hope you all understand all the concepts very well and get thorough with all the concepts. So like, share and subscribe for more updates. Keep watching my videos. Thank you, students.